Received a cordial greeting. Today we're going to talking about Wolframio. My group is made up of Stephanie Mendez, Ana Navarrete, Laura Rodriguez, and Natalia Venegas. What is the wolfram? Tungsten, also known as wolfram, is a metal of green important in the industry due its unique properties such as its X-mill high melting point and density. In its natural form, tungsten is a steel gray metal that is often brittle and difficult to work use, but I can be processed more easily. However, is a extraction and processing it has significant consequences for the environmental as well as from human and animals use are the ill known. Apply mining. Underground mining is used for tungsten or wolfram deposit in vein or locating at great depot. It is common on mineral occurred in core mining. The process tunnels or gallery are viewed to as your equipment such or drilling jumps, globed and your track or used for extraction. This method is more specimen and preset grid channel in terminal is safe and ventilation, but mineral environment impact on the surface. Open pit mining is the preferred method for large volume, low-grade wolframium deposit located near the surface. Process a pit or open kit is creating on the surface excavating the ore in benches or terraces. The ose rocket is removed to expose the mineral, which is then loaded and transportation to the process plant. This method is for cost effective for large depots but has significant environmental impact. This is landcats.
Hi, my name is Anna, and I'm going to explain you the extraction operations of tungsten. So we're gonna have 7 steps. The first one is to obtain the raw material. We have to take in mind that this mineral is not found in earth directly, but we have to find first the wolframite and the satellite, which are extracted from air crust. The second step is crushing and grinding. The ore is crushed and ground to reduce large fragments to smaller particles, facilitating further processing. And also, we use cylindrical bars or tungsten carbide cutters that we used to use in industry. The third one is the separation and concentration. We use techniques such as gravity separation, vibrating tables, magnetic separation, and flotation that are used to separate tungsten particles from unwanted minerals, like for example gunch. With this step, we try to concentrate containing a higher percentage of tungsten ore that is obtained, and which can be chemical treated, which is the fourth step. In the first step, we have the chemical processing. The concentrated ore undergoes chemical treatment. In the case of wolframite, it is melted with sodium carbonate to form a soluble salt. And then we obtain tungsten oxide. The concentrate is treated with acid, such as hydrochloric acid, to obtain tungsten oxide. And in the fifth step, we have reduction to tungsten powder. We reduce the tungsten with hydrogen. We also do it with the stream of hydrogen at a high temperature to produce the metal in powder form. And finally, on the sixth step, we have compaction. that the pure tungsten powder is pressed into molds to form bars of desired shapes. And in the seventh step is the sintering, that is the final step. The material is reheated in a furnace to compact it and make it more ductile. So we can resume that this process is more with a mix of physical and chemical processes, that tungsten is not in the earth, but we have to first look for the wolframite and the satellite to obtain this mineral. So I hope that explanation was clear, and just in a few words, this is a more chemical process, as we have to use different chemicals like hydrogen, like temperature, like acids to obtain the mineral that we are talking about, that is tungsten. So my partner is going to continue with other explanation of this mineral, and I hope that you have all this clear and that you're interested in this topic.
Hi, my name is Laura. In this opportunity, I want to talk about tungsten, also known as wolfram. Tungsten, also known as wolfram, is a strategic mineral worldwide. Its characteristic is high hardness, great density, and the highest melting point of all metals. This unique properties makes it a fundamental resource for modern technology and global industry. In applied technology illustration, today Johnson meaning has evolved thanks to advanced technology that allows for more precise and efficient exploration, extraction, and processing. Digital geology and geophysics are the foundation. Digital terrain models combine surface data, sensor, and 3D simulation. This making it possible to identify wolframite deposits with green acquired, reducing exploration codes and risks. The AI, or artificial intelligence, is used to analyze massive geological data sets and predict the most viable extraction zones. And the 3D modeling and digital twins recreate mean virtually optimizing planning and improving safety before actual excavation begins. Improving automation accelerates operation, while dreams assist iron mapping and monitoring on difficult to access areas. The Internet of Things, or IoT, connects real-time sensors to monitor ground condition, monitor and extraction process. And finally, in the technology, in the Wolfram nanotechnology open new opportunities to separating and purify the mineral more efficient and while less environmental impact. Tungsten is a list of uses, daily life and industry. In the 1 point, aerospace and defense industry using in air more precision projectiles and aircraft components due to its density and strength. In the 2nd point, securing tools and heavy machinery found in drills, milling cutters, and industrial blade recurring strain hardens in the energy and electronics and applying lamp filaments, electrical contacts, LCD screens, and devices pushed to high temperatures, and automotive and transport, part of essential alloys in ingenious turbines and high performance braking systems, medicine using in radiotherapy equipment and radiation sheltering for medical imaging, telecommunications present in transmission device and electronic components requiring continuity and stability. And everyday items found is ballpoint paintings, fish hair, and sporting goods due to its density, renewable energy used in wind turbines, and high efficiency electric motors. The historical, economic, and geopolitical importance. Historical tungsten has played a decisive role in the global economy during the world wars. It was considered a strategic resource. His hardened and density made it is essential for armor, tank shells, and ammunition. This created fresh competition among world powers, with countries like Spain, Portugal, and China playing a crucial role as suppliers. This importance, however, going beyond the story, today tungsten is recognized is a critical raw material by both the European Union and the United States due to industrial usage as the risks and supply disruptions. Current China produces more of the world's townsend, giving it significant geopolitical and market control. This dependency has led other regions to shift for alternative sources of supply. Moreover, those plays a role in the energy transition and technology innovations, from turbines and electrical motors to emerging sustainable technology is a resource essential for future development. In summary, Tunset is not only a historical military resource but also a strategic factor in today's global economy, influencing international trade, energy security, and technology competitiveness.
Environmental impact: soil erosion and habitat loss. Removing vegetation and topsoil to rain, open pit mining cause erosion which can block waterways, reduce and water quality and damage aquatic habitats. Water and soil contamination. Chemical and heavy metal used in extraction and processing can lead into water bodies, affecting farming, acid mine drains. AMD is a bit concerned releasing sulfates and metals into aquatic systems. Air emission, meaning an industrial operation relax fine tungsten particles that travel in the air and settle in soil and water, adding to environment pollution. Effects on human and animal health. Tungsten is seen as an emerging contamination because it is found more of the near mining and military areas. Animal toxicity. Disease harming aquatic life and earthworms. A study on rats show more fetal deaths and bone muscle problems when exposed to sodium tungsten. Tungsten can boil up in the GI. Human health risks. Even if it's the less toxic than other heavy metals, tungsten exposure, especially at work, can still be risky. Social impact. Community displacement. New mines may force local communities to move, affecting their way of life. Social conflicts. Mine operating can create conflicts over natural resources and land use. Historic and geopolitical conflicts. During World War II, the stargate bluff of tungsten led to the tungsten crisis between Spain and the Allies due to export to Nazi Germany. Economy as strategic importance. Tungsten is key for modern technology, energy defense, and space industries. Marketing it is critical raw material with strong global competition for supply. Job creation. Mining gives jobs, but working conditions are often hard and dangerous. Application. Tools, machinery, technology, medicine, and the military industry. Conclusion. Tungsten, although a strategic resource for industry farming and the military, creates strong social and environmental impacts. Its extraction and use pollute air, water and soil harm ecosystem, and human health and are linked to socio-economics and war conflicts, showing the need for responsible and controlled mine application.